Hey guys, the last type of reaction, finally, I didn't think you'd ever thought that you would get here. So anyway, we have combustion reactions. These are very easy to predict, but they're a little bit tougher to balance. So hang in there with me. First off, combustion reactions are for products when you combust a hydrocarbon. And a hydrocarbon is like those carbohydrates, lipids, fats, nucleic acids, even a compound with a hydrogen and a carbon, and sometimes oxygen. The products will always be carbon dioxide and water. And if you remember from our chemical reactions in the lab, I basically lit a ring of fire because I lit alcohol that I put on the table in a ring. Alcohol has carbon, hydrogen, and oxygen in it. Once we lit that, we needed the oxygen to light the fire. We put off carbon dioxide into the atmosphere, and then the wet stuff that was left on the table is water because we couldn't light that. So, again, you're always going to have oxygen here. You've got to have, oops, I'm so sorry. You've got to have oxygen in order to make the hydrocarbon burn, essentially, and then you're going to get the CO2 in the water. So let's take a look at actually how to do these. And there's a method to this madness, and I like to call it the CHO method. And if you remember from biomolecules, you had CHO, CHO, CHON, CHOMP. So it's kind of the same idea, and that CHO means carbon, hydrogen, and oxygen. So you want to do it in this step. You want to find it or in this pathway. So we're going to do carbons first. But let's first predict our products. And we know our products are going to be CO2 and water. So we're going to balance our carbons first. So what we have is 3 carbons on our reactant side. So we need 3 carbons on our product side. We have 8 hydrogens on our reactant side. So to get 8 hydrogens, we put a 4 because 4 times 2 is 8. And then finally, we need to work with our oxygen. So on the product side, we say we have 3 times 2 is 6. So we have 6 oxygens here, plus 4 more oxygens. We have 10 oxygens total on our product side. So how do we get 10 oxygens with the O2? We put a 5 in front of it. So notice I did CHO, and it worked. Hang with me here. Say I get something a little bit bigger. Oops. Let's say I have the C6H14, and let's see where I'm at. Okay, so my products are going to be CO2 plus water. And so therefore I have 6 carbons. So I'm going to put 6 carbons, and I have 14 hydrogens. Now this is going to create a little bit of a problem here. So I have 6 times for my hydrogens. And once I do my oxygens, I have 6 times 12 or 2, which is 12, plus 7. I'm going to get an odd number of oxygens here. So when that happens, there's no way to get an odd number of oxygens on my left side when I just simply have the O2. So what I'm going to do is I'm actually going to erase those 2 numbers, and you're going to go back and you're going to simply double the hydrocarbon. Now, promise this works, okay? So if I find that it's not working, I'm going to just double the hydrocarbon. Now I have 12 carbons, so I put 12 carbons in front of my CO2. I have 28 hydrogens, so I put a 14 in front of my H2O, so I have 28. Now I work through my oxygens, and I've got 12 times 2, which is 24, plus 14, which is 38. So I have to identify 38 oxygens here, and I've already have 2. So I'm going to put 19 because 19 times 2 is 38. So again, when I ran into my problem of not having the even number of oxygens, all I did was I started over again and I doubled my hydrocarbon. Sometimes you're going to see a hydrocarbon with an oxygen in it. So you'll notice here we have C3H8 and an oxygen here. So let's see how that plays into the mix. So we've got CO2 and water again. And so first we're going to go CHO. So carbons first. Carbon with the C3. So we're going to put a 3 in front of that carbon. Hydrogen is H8. So we're going to put a 4 in front of the H. So we have 8. Now we have 6 plus 4 oxygens. Our problem is we have an individual oxygen over here. So actually, in this case, we would need an odd number of oxygens. Well, if it doesn't work, what do? We go to our eraser and we erase. And to start over again, all we're going to do is double the hydrocarbon. So we're going to come over here, and where we have C3H8O, we're going to put a 2 in front of it. So we're going to double the hydrocarbon. Now we have 2 times 3 is 6 carbons. Then we go to hydrogen, 2 times 8, 16. We need 8 over here because 8 times 2 is 16. And now we have 12. 6 times 2 is 12 oxygens plus 8. We have 20 oxygens total. I come over here and I want to take 2 away because there's 2 oxygens already dealt with. So I need to deal with 18 oxygens here at my O2. So to get 18 oxygens, I'm going to put a 9 right there, and then I'm balanced. So again, the CHO method. Let me show you one that's really cool, because you'll find that if you continue to use this CHO method, you can pretty much do any type of problem. So I literally gave this problem in class today, and it freaked some of your friends out. But once they did it, they realized that they can, in fact, do this problem. So again, our products are still CO2 and water, carbon dioxide and water. Now here's the thing, guys. If you continue to use the CHO method, you can balance any of these. So first, let's check 4722. So we're going to go, we have 4,722 carbons. And then 9,446. What I'm going to find is that's going to be an odd number if I divide that in 2. So what I want to do is I realize that's not going to work. So I come down here and I'm going to erase. And what do? When in doubt, and if we can't make something work, then we start again and we double our hydrocarbon. So if I come over here and I double my hydrocarbon, so I'm going to put a 2, a 2 in front of my hydrocarbon. Now, this seems a little crazy, but I got to take 2 times 4,722, and I'm going to get 9,444. Yes, this is crazy, but there are actually molecules this big, just for an FYI. Then I have 2 times 9,446, so that's what the 9,446 is what's going to go in front of my hydrogen here, because I have 2 times there. Now, to find my oxygens, I take 9,444 times 2 plus 9,446 times 1, and I'm going to get a huge number and divide by 2. So I'm actually going to get right here 14,167. The reason why I showed you this problem here, which I know it looks crazy, there's actually molecules this big, but I want you to see you can use the CHO method, and you can use that method to solve and to balance any type of hydrocarbon combustion reaction. So there you go, you guys. You got it. All 6 reactions totally done. You made it. So I will see you soon. Take care. Bye-bye.